Hi folks, we're going to take a look at number 7b from page 233. So they're asking us to find the exact value of cosine of 23 pi over 12. And so since 23 pi over 12 is not a special angle itself, we're going to try to write it as a combination of special angles. In particular, it's likely a sum of two special angles. So because I've got this fraction over 12, I'm going to think of my special angles as fractions over 12 instead of over 3, 4, and 6, which is how we normally think of them. And so here what I'm going to try to do is, this is a pretty big number, so I don't want to start just listing all the possible special angles. It'll probably take me a while before I get to the correct combination. So I'm just going to try to split up the 23. Okay, and I try to think, well, what's going to simplify with 12? So I think if I try 20 pi over 12 plus 3 pi over 12, well, this just reduces to pi over 4, so that's a good one. Okay, and 20 pi over 12, well, let's reduce. They're both divisible by 4. This is just going to give me 5 pi over 3, which is another special angle. Special angle, though, in the fourth quadrant. Okay, so if you just we're going to end up using this diagram later anyway, so I might as well draw it out. We've got pi over 4 in the first quadrant. So that's our 1, 1, root 2 triangle in the first quadrant. And in the second quadrant, well, we've got, this is pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. So 5 pi over 3 is just going to be, as we suspected, in the fourth quadrant there. So this is going to be our 1, 2, root 3 triangle, except the y value is going to be negative, so this is going to be negative root 3. Okay, so now let's go ahead and apply our formula. So we're going to rewrite cos of 23 pi over 12 as cosine of 5 pi over 3, which is 20 pi over 12, plus pi over 4, which is 3 pi over 12. All right, and now I'm just going to apply my identity for the cosine of a sum. Okay, so here we know that that's going to be cos of the first times cos of the second. Okay, and with cosine, it's always the opposite of whatever operation you have here. So this is going to be minus sine of the first times sine of the second. All right, and now what we have is we've turned this expression into a combination of trig ratios, all involving special angles. Okay, and because I already have my diagrams drawn, I'm just going to be able to read off this answer straight from the two diagrams. Now, by the way, before I even start, 23 pi over 12 is very close to 24 pi over 12, which is 2 pi. So this angle is going to be somewhere in the fourth quadrant, so I should expect cosine of that to be positive. If I get something that's negative, I would think I'd made a mistake somewhere. Okay, so cos of 5 pi over 3, so that's just 1 over 2. Okay, cosine of pi over 4 is just 1 over root 2. Okay, minus sine of 5 pi over 3 is going to be negative root 3 over 2. And then sine of pi over 4 is just 1 over root 2. All right, and now let's just simplify this. So that's going to be 1 over 2 root 2. This is going to end up being plus root 3 over 2 root 2. So my answer is 1 plus root 3 over 2 root 2. And if I want to simplify that by rationalizing the denominator, I'll multiply numerator and denominator by root 2. So here I have to distribute. So 1 times root 2 is root 2. Plus root 2 times root 3 is going to be root 6 all over, and root 2 times root 2 is 2, times the other 2 here is just going to be 4. And there's my final answer. Okay, so just to do our quick recap here, I see I'm looking for an exact value for a trig ratio it's not of an angle which is a special angle. So the idea is to write it as a combination of a special angles. In this case here was a sum, so I could just apply my sum formula to calculate the exact value. Okay, that's it for this one.